Hey developer, Marco Arruda here. This is the third video of the series exploring ROS2 with a wheeled robot. In this chapter I'm going to show how to create a ROS2 subscriber using C++, and finally we're going to move the robot off the simulation that we have using from the first chapter. So let's do it. As usual, I'm going to use ROS2 C, so if you don't have an account yet, just click below on the link at the description, create your own account and start using it for free. So I have already my projects here, and I have created just a copy of the previous chapter, and I'm calling it already as the third chapter. So let's open it. Just wait a few seconds until we get the environment ready, and let's start working. So basically, we're working with C++. Since from the beginning, we have already created a topic, actually a node to subscribe the laser of the simulation, and right now we're gonna create a second node, which is the publisher, and finally move the robot. So how is it gonna be? I'm gonna open the IDE here, and also in the meantime I'm gonna launch the simulation, so we have everything already prepared and waiting for the publisher. So for example, first thing we gotta do here, I got to source the ROS2 workspace, and this is like this. And secondly, I'm gonna launch the robot simulation. If you don't remember exactly how we reached this point and created this launch file, so go back to the first chapter and check there. But you must have already this launch file working on your own copy of the project. So there it is. We have ROS2 launch my package dolly.launch.py. This is the launch file, and you can open Gazebo. In a few seconds, we must have the simulation already running here. And yes, there it is. Everything seems to be set up and working. So basically, we're going to create a new node. So in order to have a new node, I'm going to create a new file to represent this node. And I'm going to put it right here. So open the IDE, expand the ROS2 workspace. Then we have the source folder. Inside the source folder, we have the Dolly package, which was cloned. And then we have my package, or own package that we have created. And finally, the source folder again, but now the source folder of the package, not the workspace. I'm going to create a new file here and call it moving robot.c++. And this is where we're going to put all the code necessary for publishing something, a message in ROS2 for a specific topic. So how does it go? I'm going to copy and paste my template here. Then we go explaining line by line. So there it is. This is based on ROS2 official tutorial, so there is nothing, no secrets here, up to here, but I'm going to explain it as usual. So we have some basic libraries here from C++ that are kind of needed in order to develop and do most of the stuff in C++. Okay, then we have the ROS specific stuff, which is, for example, the ROS core libraries for C++. Then we have the geometry messages twist. And why this geometry twist specific message? Of course, if you already have worked with other robots in ROS, you may think it's quite simple to understand, but in any case, if it's not that simple for you, then you can just check here again. So go to the terminal, source ROS2 workspace, and let's check the topics that we have there. So for instance, we have the Dolly command velocity, and I want to check the type of this topic. So it goes like this: ROS2 topic type, then the name of the topic, which is Dolly/command velocity. There it is. So this is the type of the message. So it comes from the namespace geometry messages twist. So this is why we're including this specific message here. Okay, it's important to notice. Actually, it's very similar to many other robots, but if you're working with a different robot, then you want to move or public or subscribe to a specific message, this is the way you have to do. Okay, so just check the topic by the name and check the type of it. So back to the code, we're using this namespace here. And finally, we are creating this minimal publisher. And actually we can change the name. This is just the name of the class. And actually I prefer to change it. I'm gonna call it just moving robot, and this is gonna be the name of my class, and replace the minimal publisher name. And finally the name of the node, which is the name is gonna appear in the ROS environment. So if you go like this ROS2 node list, for example, you're gonna see that we have Dolly differential driver, we have Dolly laser, and finally the Gazebo. So this is the name we're gonna see appearing there. So I'm gonna change it again for moving robot. Then we have the constructor of the class, which is we are instantiating discount equals to 0, which is just a simple variable here, which is controlling the how many times we have published a specific message. Then we have a publisher here. I'm creating this just like this, create publisher. Remember that for subscriber, we have also used the this create subscriber instead of publisher. And we are inheriting this method from the node class, okay? Because moving robot extends from node. So we have to pass the type of the message, which comes from the library we have just imported here. And then we go for the arguments. First argument, name of the topic we want to publish to, and the size of queue of messages. Okay, so in this case, let's use 10. Then we are defining a timer here. And this timer is going to publish the message every 500 milliseconds. Okay, so 2 Hertz is the frequency. And then we have to bind the callback. This is very look-like to the callback of a subscriber, but actually this is a callback of a timer, and this timer callback is gonna trigger the message publisher. So just pay attention to this, because it's not that a publisher requires a callback. Actually, it's a callback of the timer, but you can also call just a publisher without having a callback, just the way it was done right here for this example. And then we have a timer, and we're using the timer callback to call the publisher in a very specific interval of time. Okay. Then we go for the private methods and attributes of the class. So first thing, we have the callback itself, which is right here is the how it's gonna work. So this is where we put the code related to the callback, and we are basically instantiating the message object, which comes from the geometry messages twist. Then we define the values we want to pass there. Okay, this is, for example, you can put anything else here, but for these specific robots, due to these degrees of freedom, of course, we can it only makes sense that you pass values to the linear x and angular z values, okay? Because we have linear x, y, and z and angular x, y, and z, but it doesn't make sense to use the other 4 attributes in this case. Finally, we are just logging some message here, so we are showing the values that we are publishing and how often we are publishing this message. And finally, we are actually publishing the message to the topic. Okay, then we are also declaring the timer variable, which is being used already in the constructor, but it has to be declared here as a private method. And also the publisher. So the publisher is being instantiated here with all the arguments and parameters and so on, but it has also to be declared in the class. And finally, the count attribute, which is also being used here on the constructor, but we're also being declared here. Finally, we have just defined the class. So remember, a class just by itself doesn't do anything. It's just a model, a template to be followed or to be used. Then we have the main function of the C++ file, and this is the one that is going to dictate the flow of the code here. And what we have here, we are just initializing ROS, passing all the arguments that we have available. In case if you want to use arguments, then ROS initializes taking into account the arguments that you have passed to the ROS2 run command or launch if the launch file contains arguments. Then we have ROS spin, which means that you won't you will wait for the flow of stuff around the class behavior. Okay, and here we are just instantiating this moving robot class that we have defined there. And it works because the moving robot, again, it's very important that you have to inherit the ROS core node. And then we have just some regular stuff here, the shutdown and return 0 for the main function whenever the program finishes. Okay, so great, there it is. I think we are ready to go. Let's try to compile. So in this case, get back to the terminal. And I have the simulation running in the first one. In the second one, I'm gonna try to compile. So please just cross your fingers and let's see if it's gonna work. Okay, so then we go for the call on build command. Remember you were compiling like this in the previous chapters. Call on build, symlink install, and then I want to select the package because you may have already noticed every time you want to compile something, not only because of ROS, but maybe because of C++, and we have many stuff here. For example, actually we have just some Dolly packages, and then we have our own package. But in this case, I think it's very nice that you learn the command to compile just a single package. So you don't have to compile everything that you have inside your workspace. For this workspace, we are yet small sized workspace, but if you go to a bigger one, then you can use this artifact. Okay, so let's try to compile it. And let me take the hook. So far we have been using many ROS2 commands, and we may be going quite fast over them. So it's important to notice that ROS2 is based on ROS1. There are a lot of things they are quite similar to ROS1, but in any case, you may feel that there were stuff they were doing in a different way, and now you have to learn everything again just because of ROS2. So if you're feeling this kind of troubles in order to work with ROS2 about packages and creating packages, compiling publishers, subscribers, nodes, and the launch file, which is very not painful. Actually, I think it's more organized, but it's very different from the launch files that we had in ROS1. So remember, we have this ROS2 basics for C++ in 5 days, which follows the same template of the very successful courses in 5 days from the construct. So this is the course where I learned ROS2, the basics of it, and I think if you go from this course, then we can follow and go throughout the series without having troubles with basic stuff. Okay, so back to the series. Then it seems everything went fine for the compilation, and then we tried to launch the node. So what is gonna happen? We are expecting to have the node moving robot. So, but actually it's not gonna work because I have just realized that we forgot the CMake file. So this is another thing that we have to be careful with working with C++ is that we don't have scripts to run. We have files to be compiled and finally to be attached to the program and order to compile and generate binary files and finally get our executables. So let's get back to here. And first thing is that we have a new dependency here. So we have geometry messages, and it has to go like this. We need to include this dependence. So find package, geometry messages, and this is required. Then we are adding a new executable file. So I'm gonna put some comments here. I think it's very nice to have. So reading laser instruction. Then we have moving robot, and we are including this moving robot executable, which comes from the file moving robot. It doesn't mean that you don't have to have an executable with the same name. Actually, we are defining just right here. Okay, And finally, for this executable moving robot, you have to use these dependencies. So ROS C++ core and geometry messages. Okay, so it depends on it. And finally, you have to install those dependencies, moving robot. So it goes like this. Then if you want to compile again, I think this time is not gonna be so fast, like within a second. So this is because it's really trying to compile the file we have just created. Okay, great, seems that like everything went fine. Then I'm gonna source the ROS2 workspace again. This is how we do it. And I'm gonna try to run it. So ROS2 run. Then we go for my package and moving robot. Okay, great. So we are publishing something, and it seems like the robots it's following the commands that we have there. Great. So let's just take a quick look again at the CLI. So we have now ROS2 node list. Oops, actually I have to source again. ROS2. Then we have ROS2 node list here, and we have the minimal publisher. This is because I haven't changed it properly, so it's just a matter of replacing the name there. But in any case, I think the most important here is ROS2 topic list, and then we can check that we have Dolly command velocity here, and you can do also ROS2 topic echo, very similar to ROS1, but this time it's not ROS topic in a single word, and etc. So just do it like this, and we can check the messages that we are publishing there. Not only the log messages that we put in the publisher itself, but also here in the CLI. Okay, great developers. So that's it for today. Don't forget, if you like this kind of video, give a like, subscribe to the channel, leave a comment, and let us know what you're thinking about the series, how we can improve it, and suggestions for next chapter. So see you there. Bye.